Hi and welcome back. Next, what we are going to do is determine the maximum primary overcurrent protection of the transformer and determine the minimum conductor size for the primary and secondary conductors of this transformer. In our example here, we have a 480 volt to 240 volt step down transformer. The transformer is rated at 10 kVA. So as you can see here, we've got one common primary winding with an iron core. That's what this symbol represents, the iron core, laminated iron core, and a center tap 120/240 volt secondary. So to determine the maximum primary overcurrent protection of this transformer, we are going to use Rule 26254, Sub-Rule 1. Transformers are very easy to calculate. You take the transformer kVA, in this case 10 kVA, which actually represents 2000 VA. Sorry, 1000 VA. So, sorry, it's 10,000 VA. Too early in the morning. So 10,000 VA divided by 480 volts, and we come up with 20.8 amps. Now in Sub-Rule 1, it says you have to multiply the primary current by 125%. So we're going to take this 20.8 amps, because that's the maximum full load current of that transformer, and multiply it by 125%. And our answer comes out to be 26 amps. Now, that is our maximum overcurrent protection that we can put on that transformer. Do they actually make a 26 amp fuse or overcurrent device? The answer is no, they do not. So, in accordance with Sub-Rule 1, you would then have to reduce this down to 25 amps. So, if you're looking at determining the maximum primary overcurrent protection of this transformer, based on 26254 Sub-Rule 1, the answer is 25 amps. We're not going to deal with Sub-Rule 3 at the moment. Next, we want to determine the minimum conductor size for the primary and secondary conductors of this transformer. If we go back to taking the 10,000 VA of the transformer, dividing it by the 480 volts, and it's the same as up here. We come up with 20.8 amps. And in 26256 Sub-Rule 1, it says you have to add an additional 25% safety factor in here. So we multiply by 125%, and lo and behold, we come up with 26 amps. So that is the minimum conductor size that we require for the primary of the transformer. So we will just write primary right here. Next is our secondary. The transformer still rated at 10 kVA or 10,000 VA, but this time we divide by 240 volts because that's our line to line on the secondary of the transformer. And then our answer is 41.2 0.67 amps. Once again, in subrule 2, it says we have to add a 25% safety factor in here. So we take the 41.67 times 125%, and we come up with 52.08 amps. Now, are we done here? Not quite. Earlier in the videos, I said that we are using copper conductor, and we are going to be basing our conductors out of table 2. Now, I'm sure Jeff spoke to you when you were doing conductors in section 4 about this nasty rule called the temperature terminating rating, 4006. When you look at pretty well 99% of electrical equipment, it is all marked with 60/75 degree conductor. We know panel boards are rated for 75 degrees C. Transformers are rated for 75 degrees C. So we are going to have to use the 75 degree C column of table 2, which is located on page 423. So have a look on the 75 degree C column. Now we're going to determine what size of conductor to use. So we're looking for a conductor with 26 amps. And oh, hey, does number 12 fit into this category? Unfortunately not. It's only good for 25 amps. So we are going to have to go with a number 10 copper conductor on this. Number 10. Next, the secondary conductor has to be rated at least 52.08 amps. So scroll down the 75 degree column. Number 8 is only good for 50 amps. Number 6 is good for 65. So we have to go with number 6 in this case. So there's our answer. The maximum primary overcurrent protection is 25 amps. The minimum conductor size for the transformer primary is number 10 copper. The minimum copper conductor for the secondary is number 6. And that's how easy it is to do a transformer. Anyway, thanks for watching. When we come back, we'll have another transformer here for you.